All right, so what we're going to look at now is section 1.5. We skip 1.4 in this book and go straight into 1.5, continuity. All right, so let's think about continuity. According to your book, we have a definition here that reads, a function f is said to be continuous at x is equal to c, provided the following conditions are satisfied. F of c is defined, the limit as x approaches c of f of x exists, and the limit as x approaches c of f of x is equal to f of c. All right, so let's see. Let's go to our first example here. Draw a function that is not continuous because it violates, and we're going to have a part A here, and part A is going to say the first condition of continuity. Violates the first condition of continuity. Now let's think about this. For a function to be continuous at x is equal to c, what did we just read? And we're going to need to go ahead and memorize this, okay? So to be continuous at x is equal to c. Condition 1 was f of c must be defined. Condition 2, the limit as x approaches c of f of x must exist. Condition number 3 was the limit as x approaches c of f of x must equal to f of c. All right, so what do we want up here? We want to draw a function that's not continuous because it violates the first condition of continuity. So the first condition of continuity, f of c is defined. We want a function that's not defined at c. Let's draw some old function here. Here's the x-axis, here's the y-axis. Now I'm going to pick an x value of c, maybe over here. Maybe c is like 3 or whatever. But it doesn't matter if I pick c there, if I pick it here, if I pick it here, whatever, okay? I'm going to draw some function, maybe that looks like this, and then an open circle right here, and then it looks like that. And that's my function f. Now notice at c here, my function is not defined. I have no function value there. Let's move on to part B. Part B. So if I look at the directions here, draw a function that's not continuous because it violates, and we're going to put the second condition of continuity. Abbreviate here to save time. All right, let's draw a function. Here's my axes, my x-axis, my y-axis. Let's pick some c, maybe over here, okay? Now, maybe there are different pictures I could draw here. Maybe I'll draw something that looks like this. Maybe I'll put like, okay, here's 1, here's 2 on the y-axis. Maybe my function does like this and has a solid circle right here. And maybe 1, 2, 3, we're at -3 here on the y-axis. And then the other piece of my function does like this. And this is my function f. Now let's see, does that violate the second condition of continuity? What does the second condition say? The limit as x approaches c must exist. Well, let's look at the limit as x approaches c from the left of my function. As my x values approach c from the left-hand side here, what is my f of x value approaching? My f of x value is approaching what? 2. So I'm going to make a guess that this is 2. It's somewhere around 2. Now let's look at the limit as x approaches c from the right of my function f of x. If I approach my c values from the right, what is my function value? What is the output of my function value approaching? It's approaching -3, it looks like. Now, what did we say for a limit to exist? Didn't we say the limit as x approaches c in general will exist if the left and the right-hand limits both approach the same number, right? What is your left-hand limit approaching? 2. What is your right-hand limit approaching? -3. Are those the same number, the left and the right-hand limits? No. So I'm going to say the limit as x approaches c of f of x does not exist. Does not exist. So therefore, the limit does not exist. This function violates the second condition of continuity. How about a third condition? How about our third condition? Let me erase all this stuff here. Third condition of continuity. What is that third condition? If I look over to the side here, let me get my pencil back. Pick a different color, maybe this one. The limit as x approaches c of f of x must equal to the function value at c. Let me draw for part C. Give you some directions first. Draw a function that's not continuous because it violates the third condition of continuity. All right, well, I'm going to draw my coordinate plane, x-axis, y-axis. I'm going to draw some c value over here. Now, I need to draw something where the limit as x approaches c is not equal to f of c. Well, I could do this. I could put, like, let's say I put 2 right here. There's nothing magical about the number 2, by the way. I just keep using it for some reason. And let's say that this is -2 right here. Let's say my function does something like this. Got a hole in it right here. Does like that. And then also I have, go ahead down here to -4, just so we don't crunch things up. Let's suppose I have a solid dot at the point c, comma, -4. And let's look back at this condition, okay? What is the limit as x approaches c of f of x? As x values approach c from the left and from the right, it looks like your function value is getting closer to 2. So I'm going to make a guess that this is equal to 2. How about the function value at c? What is f evaluated at c? Well, my function value at c is right here. So the output at c is -4. So I can say f evaluated at c is -4. Now, is the limit as x approaches c of f of x equal to f of c? No, one of them is equal to 2, one of them is equal to -4, so it fails this third condition right here of continuity.